All right, now we're going to jump into terminology related to probability. So these are the key concepts in probability, the statistics of probability. And there's some terminology we need to learn here. And the terminology is experiment, outcomes, sample space, and event. So an experiment is a process or action that produces a set of outcomes. So rolling a dice or flipping a coin, that would be an experiment. And the outcome of rolling a dice is that I'm going to get like 1, 2, 3, 4, 5, or 6. I'm going to get one of those numbers, one of those sides. The outcome of the experiment of flipping a coin will be either heads or tails. So an experiment is typically repeatable and it's subject to randomness. So an experiment is repeatable and it's subject to randomness. So examples include flipping a coin, rolling a die, or drawing a card from a deck. And we conduct experiments and then we chart the outcomes. We keep track of the outcomes as statisticians so that we could get a lot of data and then we could start to say, here's the probability of something occurring. Look, I did this. The law of large numbers means that if I do something enough and track all that data, I'm going to start to see what is generally happening. And so we run experiments and look at the outcomes to keep track of data so that we could start to develop a sense of probability based upon this law of large numbers where we've kept track of, what were the results of all the experiments, what were the outcomes. So an outcome is a possible result of an experiment. For example, flipping a coin, the possible outcome is heads or tails. The sample space is all possible outcomes of an experiment, right? So if we're rolling a die, the sample space is that we're going to get one of these. If we're flipping a coin, the sample space is heads or tails. So the outcome is the result of the experiment, but the sample space is all of the results, all of the possible outcomes, which could be realized every time we run an experiment. So every time we run an experiment, we're going to get one outcome from the sample space of all possible outcomes. So that's the terminology. And then the event is a specific subset of the sample space. So if we're trying to measure the probability of some event, once we've run an experiment and we have the sample space of all possible outcomes, and in the experiment we're seeing the different outcomes, we get all this data. And then an event will be like, what I want to see what is the probability of the event of only getting even numbers, So an event is a subset of the sample space, and that subset could be the entire sample space. Right? So, if I want to measure the probability of an event of just getting even numbers, when I roll a dice, right, that's going to be my event that I'm calculating the probability on. So we run experiments, and every experiment we run has a sample space. It has a set of possible outcomes. And when we run that experiment, we're going to see an outcome. And we can repeat an experiment over and over and over and get a whole bunch of data. And with all that data, we'll be able to use the law of large numbers, and we'll be able to assess the probability of certain outcomes occurring. When of certain outcomes occurring, right? Certain outcomes occurring, and then we could say, okay, I want to see the probability of an event, and the probability of an event will be like, okay, for this subset of the sample space, what's the probability of this subset occurring? So here it would be like, I'm just going to say if it's a fair die, it's going to be 50% because we're going to have equal likelihood that we'll get one of these three numbers over one of these three numbers right here. So calculating, so that's the terminology. And so to take a look at how you calculate probabilities, calculate the probability of an event, we use the following formula. The probability of an event is the number of favorable outcomes over the total number of possible outcomes. So for an event, right, what is like the event occurs, that's considered a favorable outcome versus total number possible of outcomes. And that's how we could calculate it. So favorable outcomes, these are the outcomes that satisfy the condition of the event. And total number of possible outcomes, this is the size of the sample space. This is when they're all like equally likely. So we could use this here when they're all equally likely. And the textbook talks about this as, I'm just looking for here, classical. It says this is classical, right? When they're all equally likely, you get the number of favorable outcomes that you want in your event. But if you've measured the data, you'll be able to look at the data to see exactly what is the probability. And so there's different types of probability. There's theoretical probability. In the textbook, we talk about this as classical probability. And it's based on the assumption that all outcomes in the sample space are equally likely. It is calculated without the need for actual experimentation. The probability of rolling a 3 on a fair 6-sided die is 1 out of 6 because there's one favorable outcome rolling a 3 out of 6 possible outcomes. And then there's an empirical probability, and they also call this, ChatGPT calls this experimental probability. And in the textbook, this is called relative frequency. So it's kind of interesting just to see that there's different phrases that people use. But if you just kind of like think about this intuitively and don't fall into that trap of I need to memorize all of the terminology and then regurgitate that on the test. But if you just logically think about it, you can make the assumption that all outcomes are equally likely. And so here, if this is my sample space and I make the assumption that all outcomes are equally likely, and I want to measure the probability of an event, say getting an even number, I could say 3 out of 6 is going to be the same as 1 out of 2, which is the same as 50 out of 100, which is the same as 50%. So however you want to do it, like in my own head, I just think 3 out of 6 is 50%. But you could reduce 3 out of 6 to 1 out of 2. And 1 out of 2 is equivalent. You can multiply the numerator and denominator by 50 each. And 1 out of 2 is equal to 50 out of 100. And 50 out of 100 is 50%. And 50% is 0.5. And so that's just math. And hopefully that all made sense to you. If you didn't, you could rewind this and play that again and play that over and then enter some of that stuff into ChatGPT to have it explain that math. But so again, don't get caught in just memorizing terminology and regurgitating it. But if we just make the assumption that, hey, every outcome is equally likely in this sample space, then we could start to calculate the probability of a certain event occurring by, what outcome are we looking for out of the total possible outcomes. That's called theoretical probability here. It's called classical probability in the textbook, but it's just like 1 out of total possible outcomes to find out like on a fair-sided die here. So don't get caught in the definitions. Just think about it logically. Are we making the assumption that all possible outcomes in the sample space are equally likely? Then that's one way we could do it. And then another way is we could look at past data. And empirical, right? Empirical is one way to say something happened in the past, right? So what's based or concerned with or verifiable by observation or experience rather than theory or pure logic. They provided considerable empirical evidence, right? Evidence from the past to support their argument based on, concerned with, or verified by observation or experience rather than theory or pure logic. So observation or experience would be things that have occurred in the past. So I think of empirical as something that happened in the past, empirical evidence. And so here you're saying, hey, empirical probability, like we've measured this, we've observed it in the past. Or experimental probability, we ran experiments in the past and we came up with some data. Or in the textbook, it's called relative frequency, right? Like the law of large numbers, we rolled this dice multiple times. And by doing that, we got all of these outcomes. And when we look at all those outcomes, we know the probability of each one of these occurring, right? Like how many times it actually empirically occurred through our experiments. What was the relative frequency of each one occurring? So don't worry about the terminology. Don't worry about trying to memorize terminology. Just think about it logically, right? Hey, the assumption that all outcomes are equally likely in the sample space. All outcomes are equally likely. Or, hey, we ran experiments in the past empirically, and we got the frequency that relative to all the other ones that each one occurs, right? So there's like, we could say, hey, we flip a coin 100 times, if we flip a coin 100 times and get heads 55 times, the empirical probability of getting heads, or the experimental probability, or the relative frequency of getting heads is 55 out of 100. So all outcomes are equally likely. We ran experiments. We did that in the past. It's empirical data, empirical evidence. It's empirical probability, or we got the relative frequency of each event occurring in our sample space. That's two ways we could do it. All outcomes are equal. We did a whole bunch of tests, law of large numbers, and we got those outcomes. And then the last type of probability is subjective probability. And this is just based upon personal judgment, your intuition, your experience from living an entire life, and everything you've experienced. And that's your own subjective experience. And so if you look up the word subjective, right, the beginning of it is subject. right? Like you are a subject, and subjective is from a subject's perspective. It's subjective based on or influenced by personal feelings, tastes, or opinions, right? So it's subjective. It's your own personal experience. So a weather forecaster might say there's a 70% chance of rain tomorrow based on their experience and interpretation of weather patterns. Or I might say that, I should be looking left and right every time I go through an intersection. Like I've seen enough cars running red lights that I need to be looking left and right every time I go through it. So here's this law of large numbers. We've talked about it, but there's a definition of it. So you can pause the video and you could read it. And then there's little kind of like applications of probability and summary. And so just to provide a little bit of review, read through that right there. Experiment, outcome, sample space, event. Right? We run an experiment, and every experiment we run, we get an outcome. And there's an entire sample space of all possible outcomes. And if we want to know the probability of a specific event, we define that subset of the sample space. We say, what's the probability we'll get this? Or what's the probability that we'll get 1? Or what's the probability we'll get 3? Right? Meaning we'll get 3, right? That's the sample space. Then we define an event and want to know the probability for event. And we ask it, we try to figure that out based upon the sample space. And there's 3 ways we do that, right? All events are equally likely to occur in the sample space. So when we run an experiment, we have, all outcomes are equally likely to occur in the sample space. And when we run an experiment, we get an outcome, right? And so that's just like, that's the theoretical probability or the classical considered in the textbook. And that's just like all possible outcomes are equal, right, from the sample space. And then there's also, we've measured it based upon different, we ran a whole bunch of experiments, and that's one way to do it. And then there's also our subjective perspective. All right, so this is like defined a little bit more up here. And so you could pause the video here and you could read through that if you'd like to read through it again. And then here is a little summary of that. And then here's like another question I asked ChatGPT just so you could see how I'm using ChatGPT to learn. So you could pause the video and you could read through that. And then here is the one that, is this one? No, this isn't the one we did. So here's another question I asked ChatGPT. Pause the video, read through that. And then here is the thing that ChatGPT cranked out. So you could pause the video and you could read through that. And then you could also pause the video and read through that. And then here is like this one here that we just went through, which I thought was the best definition. All right, so that is an introduction to probability and some terminology. And also this idea of, all outcomes are equally likely, or we just did a ton of experiments. And when we did those experiments, we kept track of all the outcomes and we defined our sample space. Maybe through the experiment, we saw what the sample space consisted of. And we saw that by seeing all of our outcomes. And then we could define an event, which will be a subset of the sample space. And we could say, what's the probability of this event occurring? So we can measure that, and then also the subjective probability and law of large numbers. Good stuff. See you in the next video. We'll continue to explore this area of probability and statistics.